And yes, and my Yuvraj Narajan, and I am working in the area of artificial intelligence almost from 2015. And this presentation will be on artificial intelligence and interdisciplinary approach for smart applications. Because from 2019, I started working in the core domain of artificial intelligence, especially in the area of smart buildings and smart cities. And my postdoctoral research fellowship program is also closely related with all smart building applications related to architectural engineering. So I think that I can make a presentation on this interdisciplinary approach, how to integrate this AI for smart applications. And let us have a small intro about this, how artificial intelligence and other things for our next 2 or 3 slides, followed up by my presentation on smart buildings and smart cities. And this artificial intelligence is trying to inculcate the human intelligence inside the missions. And how this artificial intelligence is possible. You all know that we are trying to make the missions to think. That is what AI is all about. And how this artificial intelligence is possible. And for this, we are supposed to depend on some set of programs and some set of algorithms by using their programming languages, either it may be Python or whatever it may be. We are trying to build some algorithms, and that algorithms are grouped under the category of either it may be machine learning algorithms or it may be a perfect deep learning algorithm. So based on the type of data, nature of data, we will go with either with machine learning or deep learning algorithms. So this is how we will try to integrate this artificial intelligence inside picture. And NASCOM has rightly pointed out that artificial intelligence is going to be the disruptive technology. Is when artificial intelligence, this was the statement given by NASCOM by the year of 2010. And similarly, this type of statement was given when this mobile networks were introduced by the year of 1995. Mobile network is going to be the disruptive technology. Mobile technology is going to be the disruptive technology. So likewise, by 2010 onwards, this term like artificial intelligence is coined and it was widely accepted and it was applied. So likewise, when AI came into existence, this term artificial intelligence is defined as it is going to be the disruptive technology. This is the statement given by NASCOM. With this quote, let me start with this AI for smart applications across different industries. So AI has wide application across different set of industries where there is a need to reduce the human intervention. In all such applications, this AI is playing its vital role. So there are very many applications are available, and all applications to make those applications so smart, we are trying to inculcate a normal application with AI so that that application will become smart. So various it is having applications like automotive industry, either it may be healthcare, power sector, smart agriculture, banking and finance, retail. So why not? Likewise, we have a n number of different industries where AI is crucially playing a vital role to make all the applications so smarter. So in this case, I would like to highlight few glimpse about how this AI is traveling in retail industry, because this is about building some smart applications. The interdisciplinary approach of AI. For example, you can see AI in retail is making a wonderful impact, like providing the improving the user experiences through different chatbots, reviews, market basket analysis. So likewise, AI in retail is playing a vital role, because we know that AI is playing a crucial role in e-commerce industry. In addition to the e-commerce industry, this AI is playing a vital role in the retail industry as well. And one statistics which is given in the Gartner reporters, retailers invested about 150 billion US dollars in 2020, and it is expected to reach about 350 billion US dollars by the year of 2024. So this is a small prediction given by the year of 2020, but now by 2022 itself, they have crossed about 430 billion US dollars. So this is what the impact of AI in retail industry, especially when this COVID situation was there, then probably the impact of AI got increased. So similarly, the banking industries, all the banking industries started integrating AI, especially for risk management, handling the market analysis, handling the fraud reductions and other things. So this AI is playing a vital role in banking industry as well. For your information, I would like to highlight that Citigroup has partnered with Facebook and IBM and Microsoft to develop different applications that supports the government. So this is a type of crucial initiative which is taken up by Citigroup. So likewise, many banking sectors are taking up their own initiatives to integrate AI into their existing applications. And AI in automobile, we all know this automobile industry is growing like anything, and many countries have introduced their self-driving cars, and semi-self-driving cars is almost there in picture in many of the countries. So if self-driving the car is a perfect example for a complete AI-based solution, and more than 500 organizations are working on autonomous vehicle, and US government has funded about 450 billion US dollars to develop this autonomous vehicle. And General Motors have invested about 850 billion in partnership with Lyft. Lyft is a insurance-based company. So with them, they have make a partnership to develop some self-driving cars. And AI in healthcare, many healthcare companies are there which are very interested towards integrating AI into healthcare applications. And more than 800 different startups are working in healthcare industry, and they have received a funding of about 40 billion in 2020. But now the funding, especially related to healthcare industry, is growing like anything, and the funding expected by the year of 2024, especially in the healthcare industry, is about 230 billion US dollars. So just I would like to highlight these different applications, and these are only very few applications that I have highlighted, so that to have a clear perception about how this AI is traveling, what are all the different investments that is going on in artificial intelligence. And artificial intelligence is interdisciplinary, where we are speaking about AI in healthcare, we are speaking about AI in automobile, we are speaking about AI in all such industries, either it may be retail, banking, power sector, agriculture, why not, what not, almost AI covers everything. And today, actually, I would like to give you a different intro about, because since that is my almost all my postdoc research is on smart buildings and smart cities, I would like to highlight three different case studies, because we worked on about 10 to 12 different projects, but I would like to highlight three different projects where you can able to understand the things very well, especially the applications of AI in smart buildings and in smart cities. So, nowadays, the buildings, we are trying to make the buildings so smart, like we are trying to make, for example, if we are having a big building like this, high-rise building or a commercial building like this, where this building is said to be so smart with different smart features like storage integration, air and water monitoring, keyless suit entry, climatic management, occupant sensing, and HVAC monitoring, lightning management, building surveillance, EV charging, keyless parking. So likewise, if a building is having all these facilities, then such buildings are said to be AI-based smart buildings which can able to do all these types of management by its own. So this is what we call it as smart building. And whereas this monitoring like heating, ventilation, HVAC monitoring, heating, ventilation, and air controlling, air condition monitoring, that plays a vital role in the case of smart buildings. So nowadays, even in India, in almost all tech cities, the smart buildings are evolving or evolved and started evolving with many, many, many features. And you can see, we are speaking about smart cities. Many funding is opening for smart cities, and all the government is focusing on making the cities so smart. So if a city is said to be smart, then like all these things should be there in that picture, all these should be there in existence, like smart healthcare facility should be available. So normally if a city is having a good infra, then it means like it is said to have a good healthcare, good infrastructure, good technology, good citizens, likewise. So if all these things are available, we used to highlight that city as a good city, good structured city. But when we want to make that city as a so smart, then the healthcare system should be smart, The buildings should be smart. The mobile communication should be smart. The infrastructure should be smart. So energy should be smart. Citizens should be smart. Education should be smart. So likewise, all these things should be so smart to make the cities as smart cities. And all the interconnected buildings you can see in smart cities, the connected buildings, the buildings are getting connected to make smart cities. So you can see connected buildings are said to be some intelligent buildings where smart workplace will be there, and all these facilities like open architecture, IoT, smart technology, occupant interaction, predictive analytics. So like this, all these facilities will make this smart building. And you can see a single building is said to be a connected cognitive building. So cognitive building means every motion inside the building will be observed, it will be measured, it will be predicted, it will be observed. So such buildings will become smart building. And when the smart buildings, when the smart buildings tries to make some decisions, smart buildings tries to support some other buildings or other vehicles, then it will become intelligent building. And one building can connect with each other, so it will become connected building. So likewise, this is the connected building structure of smart city architecture, where a building is a cognitive, followed up by smart building, followed up by intelligent. And when this building is intelligent, when these buildings can be interconnected with each other to form a connected building. So like power utilizations can be shared, and how many occupants are there, any emergency situations happen, how it should behave. So likewise, all the interconnections are possible in the case of smart buildings. And when all the smart buildings are connected with each other, one building can interact with other, so that this connected buildings will form the foundation for smart cities. So this is a core structure of smart buildings and smart cities. And here, this structural health monitoring, artificial intelligence and structural health monitoring, because this is an, since it is the topic is about artificial intelligence as an interdisciplinary approach. Interdisciplinary approach, I want to take a completely an interdisciplinary approach. So that is why I have taken up a concept of structural health monitoring, which is one of the main vertical in architectural engineering. So artificial intelligence and structural health monitoring, how does artificial intelligence can be integrated for monitoring the health of the structures? So you can see what is mean by structural health monitoring. When you take a building, either it may be a concrete building or it may be the building made up of steel structures, many things may be there, like the strength of concrete structure, or a strength of a steel structure, or a strength of a glass structure. Everything is called as structures here. So the health of the structures during a particular duration of the building, lifetime of the building should be monitored, and it should be evaluated, it should be predicted. So that concept is called as structural health monitoring. For example, if you take a concrete structure, there are various damages that may occur, like cracks may occur, or concrete spalling may occur. Or so these are all the main problems that may occur in a concrete structures, and this should be monitored, and that is called as structural health monitoring, concrete structural health monitoring. For example, if you take steel structures, so these steel structures may have different type of damages. Either the steel frames can be damaged, it can be bent, or it can have some corrosions which will affect the durability of the building. So this is what we call it as structural health monitoring of steel structures. Or if you take like road structures, that is also we call it as the damages which occur during the earthquake. So the damages which occur during the earthquake, like earthquake analysis, this pedestrian reductions, these are all become a part of structural health monitoring systems. So how this artificial intelligence can be embedded uh, to monitor all these structural health monitoring. So this is what today's presentation will be, and I have planned for 3 different case studies. And before getting into this, again, this artificial intelligence, yes, uh, we will try to make the machines to be very intelligent, so that they can able to think by themselves. And that is possible by designing some algorithms. Algorithm means step-by-step instructions to step-by-step instructions that can be communicated to a machine. And that algorithms can be grouped under different categories like machine learning or it may be deep learning. If the data set is so large, if the data set is so diverse, either it may be video, audio, speech, something like that, then the machine learning algorithms may struggle to give some good performance. So we will go for deep learning algorithms, so which can give a better performance when the data set is when the data set is large. So what are the steps in building the AI models? I hope you might have came across the same set of studies during the last sessions, but it is very simple. Like you want to have the data, get the data, prepare the data. That is, you want to clean the data. That is, removing some noises, removing the errors. So these are all we call it as preparing the data. Train the model. You want to train a model. Train the model means create an algorithm. Create an algorithm. Either you can go for machine learning algorithm or you can go for deep learning algorithm. And once your model is ready, you want to test the data, whether how your model is performing. If the model is performing good, then we can able to improve the performance. Even if the model is not performing, we will try to fine tune something here in the model, and we will try to improve the model. So this is what a normal steps involved in AI model building. But even though this 5 steps looks very simple, it is not that so easy. Where a different getting the data is a different vertical, cleaning the data is a different vertical in data science. Training a model, that is designing a model, is very because when you speak about machine learning algorithms, there are hundreds of algorithms are there. When you speak about deep learning algorithms, different variations of different architectures of deep learning algorithms are available. So based on the available data, you want to fix which algorithm best suit for to build the model. So that is what we call it as training the model, and then test the model. Once the model has been trained, we want to test how the model is performing. So likewise, we will test the model, and finally uh, the model can be improved. So this is how we will start. And I will go with the first case study, like computer vision for identifying the damages in steel frames. How the damages in the steel frames that can be identified. So here you can see, this is the steel structure. And these are all for your information, these are all the core research work that we did as a part of a postdoc research fellowship program funded by National Research Foundation of Korea. Because in Korea, almost all buildings are high-rise buildings, and there will be minimum of 30 or 40 floors will be there. 40-story building will be there, and many buildings are maybe of concrete structures, and many buildings maybe of steel structures. Based on the duration, they will try to go with concrete or steel structures. And here, in the case of high-rise building or in a normal building, when we make use of the steel frames for designing the structures, there is a possibility for different type of damages that may happen over there. The damages can be like, it may be corrosion or it may be some bending. The deformation of the structures can be some of the damages that may occur in the steel frames. So when you take this as a case study, then you can see like how normally without AI, how they are doing us performing the analysis of steel structures by using manual inspection. The persons who is available, engineers who is available, they will make a manual inspection periodically to check whether there is any damages in this high-rise building or not. So this manual inspection will be very difficult, especially in the high-rise buildings, and it will not be efficient as well, because uh, it is of a very vast area. Making all the manual inspection across all the locations will be very difficult, and maybe it might not be accurate as well. So here in this case, we can go for AI-based inspection by artificial intelligence, where we can able to build some model and we can integrate it with drones and it can be used for inspection. and it has its own advantage, like it is very easy, efficient, and almost everything is automated. No need of any human inspection there. So this is one project that we have worked with. Like, yes, we identified some steel frame structures, and this is a proposal like steel frame structure is here, some drone is here, and this drone is embedded with deep learning architecture. And when this drone tries to inspect this building, yeah, then it can able to come up with classified results. Here we have some damages, here we have no damages, like that. So for that, this is a small architecture where if we want to identify the damages in steel frames, then we want to generate a steel bar dataset, and that steel bar dataset can be grouped into training and testing, because this testing data can be used for model validation, and this training data is uh, used for model building. So this is what the architecture. So once the model is trained, then this model will come here like this. Model evaluation will be there, and for model evaluation, we will make use of some testing data, and we will check how the model is performing. So this is a complete architecture of the end-to-end model. And to start with, because especially when we speak about the research and other things, we should start with data collection part. Likewise, this is what I would like to highlight. Like this is we did in our lab, where we got some steel frames. We intentionally damaged few steel frames. And there are a few frames without some damages, and with that, n number of images will be captured with the different angles. With different angles, the images of the steel frames will be captured, and all are grouped under different categories. For example, all the damaged steel frames are grouped under one category, and undamaged steel frames are grouped under different category. So in this, almost we make use of almost 2000 images, where 1000 for damaged steel frames with different angles and different distances. Because when you make about when you are preparing a data set, that data set should be very diverse. It should be of it should have different combinations. So that is why the camera angle will be different, the distance will be different. So likewise, we generated almost 1000 different images of damaged steel frames, and 1000 different images of undamaged steel frames. And now we developed a deep learning model by using deep convolution neural network. It is a self-configured architecture. We configured a CNN architecture especially for this particular purpose. We have not make use of any pre-trained models, because when you speak about deep learning, many pre-trained models like VGG, 16, ResNet, MobileNet, likewise many different architectures are available, but this is a customized architecture by overlapping various layers, and deep convolution neural network has been designed. And here in this case, like one this when you try the model has been trained, this model, deep learning model, has been trained with the training data, and when you make this testing data as an input to this trained model, this is a trained model, kindly imagine this is a trained model, trained deep convolution neural network model. When you give a new image, and consider that this image we have intentionally giving like this, but normally in real time, this will be live feeded by live stream video analysis. The drone will capture, and it will live, the captured video will be passed as a live stream to this model, and you can see a feature map will be generated. And for your information, this is a damaged steel frame, and the feature map will be like this. And when you upscale this feature map, for example, if the pixel size of this input image is about, for example, 2300 cross 1800, then this will be downscaled images, which is of about 500 cross 200, and it should be upscaled. And when you try to overlap this upscaled image with the original image, you will get an image like this, where you can able to identify that this image, what the insight is, this highlighted portion is a damaged portion. This highlighted portion is a damaged portion. So likewise, yeah, different visualization like GradCam visualization is available. So this is how the research is going on, especially by integrating artificial intelligence for structural health monitoring. Similarly, this is another input, and this is an undamaged steel frame, and there will not be any overlapping here. So this is how we are trying to train the missions, train the models, train the missions, and trying to prepare a complete automotive setup. And now we are working on, for your information, we are working on integrating this model inside drones so that we can able to make a live analysis, and that project will also be over within next 1 month. So it is in progress for your information. The model is developed, integrating, configuring drone is in progress. So that is one work that I would like to highlight, how this artificial intelligence can be used as an interdisciplinary approach for smart application. Application is monitoring the durability of the building is an application. So we are trying to make that application so smart by integrating that application with artificial intelligence. Similarly, this is one more interesting case study, especially on tall buildings. I would like to, I'm not interested to go much deep in this, because this will speak all thing about wind engineering. Maybe this will be something. Okay, but anyway, for your information, please try to understand, like in almost many abroad countries, there is a high-rise building, and as a part of structural health monitoring, the wind flow will be monitored. The flow of wind, velocity of wind, how the wind flow is, likewise everything will be monitored. And the response of the wind-induced response will also be monitored. So here, for every location, there will be some response. When the wind is there, when it touches the surface of the building, it will have some response. Response may be like vibration or something like that. When the vibration is something abnormal, then the problem is there is some problem with the structures. So this is how an automotive surveillance or monitoring system is working on. Now, this is one work like this response system. This response system is taken care by the sensors placed in the building. So for example, if you take this as a building, you can see many sensors will be available. These sensors are HVAC sensors. Either it will be used to analyze the heat or air condition, ventilation, wind, anything like that. So here you can see this pressure sensors will be available. But the problem with this pressure sensor is, you can see all the sensors will not be perfect all the times. That is the main drawback in placing the sensors. So here you can see this red sensors are correctly working sensors, and yellow sensors highlight that sensor is not working correctly. And for example, there is one more color called purple is there, where it highlights that there is no sensor, but just I want to identify how the wind responses in that particular place. So likewise, many research is going on. So here, now I can able to get the response here, but here I can't able to get the response because that sensor is not working. So if any fault is occurring here in this particular place, it is very difficult for verifying how the how is the quality of the building, how is the quality of the structure there. So in that cases, we can try to build an imputation model, data imputation model, so that even when any sensor fails, we can design an artificial intelligence model. That model can able to impute the data when the sensor is not working good. So that is one of the important application of integrating artificial intelligence for pressure prediction. What is the wind pressure which is generated? So we worked on an algorithm called GAIN, Generative Adversarial Imputation Network, and that algorithm will get trained by, this is a wind tunnel test. I don't want to dig it go in depth. So this is how we will generate the data, because in the last example I showed how to generate the data. So here the pressure data will be generated in a lab setup like this, and this is setup is called as wind tunnel test. So by using the data generated here in the wind tunnel, the model will be trained. So the trained model has the capacity to impute the data, to fill the data when some sensors have failed to generate the data over there. So this is an example for data imputation model, and this model works with GAIN, generative adversarial imputation network. So here you can see this is a normal building, and here if any faulty sensor is like this, and the data, when the wind flows like this sensor will generate some data and the vibration will be analyzed. If the vibration is normal, then there will not be any alert signal. When the vibration is abnormal, sorry, some alert messages will be given to the people who is there in maintenance. So here, even if the sensor is not working, this intelligent model will take care, fill the values, and based on that, either the alert may be given or may not be given based on the value which is predicted. So this is one of the main application of artificial intelligence for structural health monitoring, especially monitoring the wind-induced pressure on the high-rise buildings, on the high-rise buildings. So this is one of the main application that we have worked on. And I think this is an interesting thing when you really work on the real-time data set, and the data set that I have showed in the last case study is of images, and this is of time series data. For every millisecond, a sequence of jet data will be generated and that will be analyzed. That is a time series data for your information. And yes, this is one of the work, as I already mentioned. The first work is about steel frame damages, and this one is damages on concrete structures. Damages on the concrete structures, for example, either the concrete structure may have some cracks, how it can be analyzed. And here, either this is the same way around, manual inspection is not possible. You can go for automatic inspection by using drones. And the main challenge with this drone is, like we can able to build some small models, because deep learning models are so big in nature. Actually, the size of the model will be so huge, so that it will be very difficult to integrate that model with the drones. When you try to build a model which is very small in size, then the performance will be so good, there will not be any latency. So for that purpose, this work specifically concentrates on building a shallow CNN architecture. In the first case study, I have showed you a deep CNN architecture. Deep means when the number of layers in the CNN architecture will be so huge. So when the number of layer increases, the size of the model will be so big. When the size of the model is so big, we need that type of drone, that type of capacity, that type of computational power to process the data. But whereas when the size of the model is small, then we can go for some low-end architecture. There is no need, the dependency will be so minimum. Infrastructure dependency, processing dependency, everything will be so minimum. So in that case, we will go for such an architecture. And here you can see this is an we have not generated this. This is open source and it is available in an open source where different set of crack images, non-crack images are available. We will make use of these images for model training. And you can see this is shallow CNN architecture that has been developed with a very minimum size. And you can see the name of the architecture is LeanNet 5. And this is the first time where LeanNet architecture, LeanNet is the first CNN architecture which was introduced. After that, many architectures came into picture. But even now, we proposed a LeanNet based architecture for identifying the damages in steel frame, especially the reason behind going behind this LeanNet architecture is this is a shallow architecture, so the size of the architecture will be so minimum. It is, you can see here, the size of the architecture is, it will occupy only 26 MB. You can see all other architecture is almost 500, 100, 100. So when the that increases, then probably the number of parameters. You can see how many parameters are here. So it will take a huge time for computation. You are supposed to depend on such infrastructure facilities for computation. So here in this case, we proposed a shallow CNN architecture, which has the capacity to perform in a similar way of other deep CNN architectures to produce the results. So sorry, this is not damaged steel structure. This is not damaged steel frame, damaged concrete structure. So this architecture, shallow CNN architecture, will be embedded inside the drone. This drone will make all the surveillance across this high-rise building, and it will try to identify whether there is a crack or non-crack as a part of live stream video analysis. So, yes, with this, I would like to stop my presentation and I would like to highlight this presentation is mainly focusing on integrating artificial intelligence for interdisciplinary approach. Artificial intelligence is not only for banking. We may think like it is for banking, it is for e-commerce. No, many applications are there in materials, many applications are going there in automobiles, designing the wind turbine, designing this all architectural engineering stuffs related to wind engineering. So this has a huge application. So keeping this in mind, we can go for developing artificial intelligence based approaches for building some smart application in almost in all interdisciplinary domains. With this, let me stop my presentation and I am open for queries now. Thank you so much. Thank you so much for your patient listening.
So 1 second, I'll unmute all participants so that they can ask their queries.
Yes, madam, please.
Okay, so participants can now please unmute yourself and ask questions. I think there's one student, Jitendra.
Yes, sir. You sell the crack detection using this drones now, sir.
Yes.
What could be the range that drone can detect, sir? Like how far? Like if you are flying parallel to the building, like what is the range that it can detect?
Actually, our experimentation is based on, we tried with the 3 different distances. Actually, the maximum distance is 1 meter that we have tried. Maximum distance is 1 meter, whereas we tried capturing the images at 3 different distances. One is 30 centimeters, and next is 60, and then about 1 meter. So this is how we have trained the model, and that is how the model can be integrated with the drone so that it can able to perform good.
Okay, sir. Thank you.
Yes, thank you so much.
Kaushik, do you have any queries to ask?
Dr. Mohammed Parvez.
Sir, good evening, sir.
Yes, madam.
Sir, it is too short distance, 1 meter, na?
Sir, actually, the point is like, this is a research that what we did and that has been given. Only thing is, you can, that 1 meter distance in the sense, the distance between the wall and the drone is 1 meter. Wall and the drone is 1 meter. That is what we have tried. The point is like, a deep learning model, or it may be a machine learning model, or any AI models is only based on the performance of the model is only based on the data that you have used for training. So the data what we have tried is with the maximum distance of 1 meter. So that is what I'm saying. If you can able to capture the data with a distance of 2 meters, and if you can able to train the model, surely that model will can able to perform much better.
Okay.
Yes.
Thank you, sir.
Yes, thank you so much.
Good evening, sir.
Yes, madam.
Good evening, sir.
Yes,
Sir,
madam.
is it like real-time implementation that you're telling, sir? 1 meter
Ma'am, yes, ma'am.
detection. So the
Yes,
crack
yes.
detection was implemented in real time.
Yes,
But
ma'am.
once you were telling like the images captured were streamed to somewhere else, like control station. What is the purpose then of sending the data, sir?
What, ma'am?
During your presentation, you was telling like the images will be streamed to somewhere else, maybe like control station. So what is the purpose of sending the drone captured images to
Ma'am,
somewhere else,
drone
sir?
captured images, the drone will capture the images and we are supposed to have any UI. The UI can be a web-based UI or it could be a mobile-based UI. So that the live stream video can be captured, processed, and you can able to see when the drone is flying, we can able to see where it is captured and whether it is having any cracks or not, whether there is a crack,
Defect.
whether there is any damages or not. So from the UI, you can able to see that.
Okay, sir.
Yes, ma'am.
Okay, sir. So is there any sufficient time method, sir, to tell the at
Yes,
what
ma'am.
fraction of second or what timing the result the defects are identified, sir?
Ma'am, sorry, ma'am, your voice has breaked. Yes, please, can you repeat?
Sir, is that like computational speed in terms of time did you measure, sir, to
No,
identify
madam.
the
No, no,
defect
no.
during real-time
Surely,
processing?
yeah.
No.
In
Okay,
real
sir.
time, there is a huge delay is there that because we have not make use of
Okay,
any
okay.
computational things.
Okay, sir.
But we worked on the
Okay, sir.
performance, whether it can able to detect or not. Till that level, it is there. But the delay and other things are there, and it is only based on the type of infrastructure that we are using.
Okay, okay, sir. So that
Yes,
is the reason why you went for shallow type of CNN
yes, ma'am. Shallow architecture, but
models.
shallow architecture we have not yet tried with integrating with the drone, but it is proposed and it can be done actually.
Okay, okay, sir. Okay, sir.
Yes,
Thank
ma'am.
you, sir. Thank you very much, sir.
Thank you so much.